Hey everyone, welcome to 2.3, the quotient rule. And so in words, the derivative, I'm not going to read all the rest of that. If you really want to see the words, go back to 116. It's really similar to the product rule. So we're just going to skip all those extra words and just go right to the formula, save you some time. So it says the derivative of this function, f of x over g of x, both of them are differentiable, is g of x, f prime of x, minus f of x, g prime of x, all over g of x squared. Okay, and down here is another form of that, and if to remember this formula, here's some helpful hints. B comes before t in the alphabet, thus the bottom function times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Something that will hopefully help you kind of remember this. Okay, so here's our example number 1. 5x minus 2 divided by x squared plus 1. So what we're going to do first, it's going to be g of x. It's that first one. Let's put parentheses around it. It's the first one, so it's going to be x squared plus 1. Put it in parentheses. And it's going to be times the derivative of this top one. So 5x minus 2, the derivative is just going to be 5. Okay, then we're going to do minus the top one, which is 5x minus 2. Put that in parentheses, and we'll multiply that by the derivative of the bottom one, x squared plus 1, so that's really just going to be 2x. And that's all going to be over x squared plus 1 squared. Okay, so far so good? Great. Okay, next what we're going to do is distribute that 5 into both of them and the 2x into both of them. And we should get something new, so we're going to get a new marker. So 5 times x squared is going to be 5x squared. 5 times 1 is plus 5. Minus, now make sure of this minus. This is going to trick some of you up because you're going to get the wrong answer, and it's because of a negative, nothing else. Okay, so we have 5x times 2x is 10x squared, and that is going to, let's just keep this in a parentheses for now. And negative 2 times 2x is going to be negative 4x. Alright, all over x squared plus 1, if you want to think about x squared plus 1 times x squared plus 1, you want to do it that way, so you do x times x will give you x to the 4th, and you know what, we're going to just leave it as x squared plus 1 squared right now, because then what might happen is maybe we'll be able to cancel some stuff out. So we're just going to wait on that for just a minute and see what happens. Okay, so it's going to be x squared plus 1 squared. Now we're going to do minus this and minus that, which means that one really becomes a plus 4x. So we've got negative 10x squared plus 5x squared is going to equal negative 5x squared. And then it's going to be minus 4x plus 5 all over x squared plus 1 squared. Okay, now, can I do anything with this top thing to make sure that it goes a little bit better? Let's find out. So after going back to my math layer, I just found out that I can't really do anything with those. 5x squared minus 4x plus 5. I could try the magic x, see if I can factor anything. It's not going to work. Quadratic formula is completely useless because it would tell me what the answers were, but that doesn't tell me if I can factor anything. And I want to be able to factor this so I could kind of cancel some stuff out. Since I can't cancel anything out, we're done. So that would mean that we could say d dx of 5x minus 2 over x squared plus 1 is going to equal that whole thing, negative 5x squared minus 4x plus 5, all over x squared plus 1 squared. And some of you might be saying, but Mr. Bartman, do we have to do anything with that denominator? And I say, no, you don't. As long as we can't do anything here, you might as well leave it. You might, in a multiple choice, they might have this kind of factored out, but I would bet that they're going to leave it just like this. So don't do the extra work. Leave it just like it is. Okay, and now let's do example number 2. Find the derivative of 3 minus 1 over x divided by x plus 5. Now what I don't want to do is I don't want to leave all this here like that. It looks bad. It's no good. So what we're going to do is I'm going to get rid of x in the denominator by multiplying the numerator by x over x. Okay, so that means I should be able to do something like this. Let me just write it down. Okay, so I want to have all these denominators be over x. So I can say this would be 3x over x minus 1x. I'm sorry, just 1 over x. So that way I can rewrite this numerator, that whole part, as 3x minus 1 divided by x, all over x plus 5. Okay, so now instead of dividing by x in the numerator, I hate it when I've got a double fraction, that guy can just go down in the denominator because we're dividing by it, so it's like multiplying by the reciprocal kind of stuff, so it's going to go into the denominator, which means we can rewrite this as 3x minus 1 over x squared plus 5x. Now I've got it in a little better form that now I can find the derivative of this function. Let's just say it equals f of x, not prime, so we can say, what I was trying to go for is, let's say f prime of x is going to equal. Now let's see, do you remember what the formula is now that it's no longer here? Well, that's okay because it's actually that way over here. If I can't keep going, it's right over there. See it? It's right here. Also, it's down here. Okay, good. So f prime of x is going to be the top one, so we're going to find the derivative of the top one. Derivative of the top here is going to just be 3, and that's going to be multiplied by the denominator of x squared plus 5x. And then we're going to subtract the original numerator, which is 3x minus 1, times the derivative of the denominator, which is going to be 2x plus 5. Okay, all over x squared plus 5x squared. Okay, so now let's do all sorts of stuff. Let's clean this up, right? 3 times this stuff right here, and then we're at the FOIL here. Don't forget that this thing with the minus right here, I'm probably going to do that at the end because I don't have to do too many steps. So 3x squared, so I'll get it as 3x squared plus 15x. And then we're going to do minus. I'm going to put minus and put all this other stuff in parentheses. So 3x times 2x is going to be 6x. 3x times 5 is plus 15x. Negative 1 times 2 is minus 2x. And negative 1 times 5 is negative 5. Okay, now let's combine as much as we can after we put this all over x squared plus 5x squared. Okay, there we go. Now, what we're going to do is we are going to combine this stuff. That should be a square right there, too. Alright, hopefully you can see that. Should I zoom in just a little bit for you? Well, if you didn't want me to, I did anyway. Sorry. So, 15x minus 2x is going to be 13x. So we're going to write this as 3x squared plus 15x. I'm going to do the minus 6x squared, distributing that minus in. 15 minus 2 is going to be 13, so it's going to be minus 13x, and minus a negative 5 is going to be plus 5. All over x squared plus 5x squared. Okay, I know I'm running out of room. If I have to use another page, I definitely will. Let's see if we can get one more on here. You know what? Let's not even see if we can get one more on there. We're just going to go right on to this next one down here. Down here. There we go. We'll go right to here. So now we've got this thing right. Yeah. Okay, so now combining my like terms, I've got 3x squared minus 6x squared is going to be negative 3x squared. 15x minus 13x is going to be plus 2x plus 5, and that's going to be all over x squared plus 5x squared. Alright, now can we factor all this stuff? What numbers multiply to 5? It add 2, and then with the 3, let's see if we can factor this out. Let me go to my mind palace here for just a second. Alright, and no, we can't factor them, so that's going to be it. Alright, so that is our answer for f prime of x. See it? There you go. Alright, so there are a couple of examples of the quotient rule. Here's a couple of helpful hints before you really get through a lot of them and you say, ugh, I hate the quotient rule. There's so much work. I don't want to do it all. I understand. So, rewrite. Cancel stuff out so you don't have to use the quotient rule. It's long and complicated, and there's a lot of stuff that you don't want to have to worry about. So if you can see a denominator and say, I don't want to do that, okay, then don't. Alright, so we could actually rewrite this as 1/6 x squared plus 3x. There. Now we don't have a denominator. Now we've got a constant times our function. We can just we can find the derivative of this thing multiplied by 1/6. Done. No quotient rule necessary. Same one as this one. We can say this is the same as 5/8 x to the 4th. Again, no quotient rule. No problem. Alright, this next one you look at and say, well, I have to use the quotient rule. I've got a 7x, so I can't just say there's a 7x out in front because that's not a constant anymore. Yes, but if you look at, can I factor this out? They both have an x. This would be the same as negative 3x, 3 minus 2x, all over 7x. X's will cancel out, so we can be left with on this one is y is going to equal negative 3/7, 3 minus 2x. And then you can do the same derivative function rules that you have been doing for this whole time. Okay, and lastly, here's some bonus material. All right, you've got derivative of trig functions. Dx of tangent is secant squared. Dx of cotangent is negative cosecant squared. Ddx of secant is secant tangent, and ddx of cosecant is negative cosecant cotangent. I know it's a little hard to see negative cosecant cotangent. There's your bonus material for today. All right, good luck.